chapter 12, 11 and 12, rather. Again, we had to smush things together. So today is the 19th, and you can see that you don't have school on Friday, no school on Monday. And so these are the 8 days of notes. We've got 8 days of notes left. And then you have your review and test, and then final exam review and finals. So this is the whole year. That's the plan. And I just want to remind you today, you can do test corrections today and tomorrow. And there's not a ton of test corrections left, so it's a good idea to get those done for those points, because they are important. All right, so today we are looking at section 11.3 in your textbook, which again, you can return your textbook to the Media Center whenever you get a moment. Okay, all right, I do want to remind you today, you can see on here, 11.3, this is out of your book. It's find angle areas of rhombuses and kites and quadrilaterals. On Friday, we went over all the formulas for areas of trapezoids and triangles and what have you. And I'm going to add one more today, but today we are really going to spend our time on areas of regular polygons. So, example 1 here, we want to find the area of each regular polygon. Now, just to remind you, a regular polygon is here. You can see the first one here has been inscribed in a circle. And to be regular, it means that all the angles are congruent and all the sides are congruent. So a square is an example of a regular polygon. And the reason we're going to inscribe this in a circle is because we have some vocabulary. So you can see right here, I have a 1, 2, 3, 4, 5-sided polygon. So this is a pentagon. And it is a regular pentagon. And I inscribed it in a circle because I want you to recognize that we have the center of our circle, and there's a little bit of vocabulary that we need to do in order to figure out the area of that polygon. I know how to find the area of a circle, but I really need to figure out how to find the area of this pentagon. And so first is that I have so many sides. What I would like to be able to do is figure out, you know what I see when I look at a polygon? I see lots of triangles. Do you see lots of triangles?
I do see a lot of triangles.
Yeah, so how do you think we might be able to figure out the area of that pentagon then, knowing that we have a bunch of triangles? So do you think that maybe I can figure out the area of one triangle? Okay. And then times it by 5. That's exactly right. So as our broad strategy for finding the area of a polygon, we want to go ahead and find the area of one triangle and then just multiply it by the number of triangles. And that generally is going to work for any regular polygon that we want. So our job is to figure out the area of one of these little triangles because they're all congruent. They all have the same base length here. And so I need some information now to figure out how to find the area of this triangle right here. First, I want to find I'd like to find the measure of the top of this triangle, which is called the central angle. How are we going to figure out how many degrees this little central angle is? 360 degrees, that's true. Divided by 5, absolutely. So we know that this is why I inscribed it in a circle, because they all fit inside a circle. We know that there's 360 degrees in a circle, and this is a pentagon, so we want to divide it by 5. So we're going to divide it by the number of sides, and it turns out that 360 divided by 5 is 72 degrees. Now, I'm going to do some fancy math right now. Okay, so all of these central angles here are 72 degrees, and what I need, in order to find the area of this triangle, I need to know the base, which maybe they'll tell me in a minute, I don't know. And I need to know the height. So what I'm going to do is I'm going to drop an altitude that's going to split my triangle into two congruent triangles. So that altitude forms a 90-degree angle, and this thing has a special name. This line that I just drew, that altitude has a special name called the apothem, A-P-O-T-H-E-M. That is an apothem. It starts with an A, sorry. The apothem goes from the center of the polygon to the middle of that bottom side of your pentagon, okay? So it's always perpendicular to that side. And then I also have another name here that we want to make sure we realize, and this line that goes from the center of the circle to a vertex of our polygon, that is called a radius, and it's called a radius because it is touching that circle. So it literally is the radius of that circle, okay? So there's two vocabulary words here that we need to know. Radius goes to the vertices, so all of these little central angles I drew are all radii, and then we have the apothem, which goes perpendicular to a side, okay? Now, I know that this altitude just split my little base there into two congruent pieces. And in order for me to find the area of this triangle, I'm going to need the length of the base, and I'm going to need the height of the triangle, all right? And so I'm going to give that a name. Let's see, so here, it told me if the apothem is 8. So this height is 8 in this particular polygon. Okay. We want to find the area. So what I need to do is I need to find the length of this piece, and I'm just going to give it a B for the little base there. And I want to figure out that base. And I'm going to use trig. So this is actually a really great review of trigonometry today, what we're doing. We had a 72-degree angle, and then I drew in this altitude, this apothem, and what happened to that 72-degree angle? It got split as well. So 72 divided by 2, now those angles are each 36 degrees. So I have this little 36-degree angle. This one over here is also 36 degrees, but right here is a 36-degree angle. And I can use that because I have a right triangle here, so I'm allowed to use trig. Looking from this 36-degree angle, which side is this? Opposite. Yeah, what do we remember from trigonometry? SOHCAHTOA. SOHCAHTOA. Again, you might want to write that down as just a reminder. So we have the opposite side, and we have, what's the 8 going to be? Adjacent. Very good. So we have the opposite and adjacent, which means we're going to set up a tangent equation here. So the tangent of my 36-degree angle is opposite over adjacent. That's going to be B over 8. How do I get B by itself? Times by 8. We're going to multiply that 8 over to the other side. So we get 8 times, oh, I need to be in degree mode. Got to be in degree mode. Make sure you're in degree mode.
Oh, you have to go to head mode and then you have to
yeah. Tangent of 36.
It's right next to second.
I'm on.
It's right in there.
Am I in degree mode? Oh, you're in radian mode.
Make sure you're in degree mode,
Why am I in radian mode?
because radian is regular and what we always use in any other class than this one. All right, so we get 8 times the tangent of 36 degrees is b, so b turns out to be 5.8123. I'm going to go with 4 decimal places right now, which should be fine. Okay, so this b is 5.8123. So my question to you is, I need to know, in order to find the area of the triangle, the whole base. What does the whole base equal? Yep, you times it by 2. So I'm just going to take this answer that I have in my calculator and just write times by 2. That way it doesn't round anything off. So my whole base is 11.6246. Okay? All right. So now that we have the base, to find the area of our polygon, I want the area of the triangle. How do we find the area of a triangle? Nope. Almost?
Oh, wait, it's a triangle.
1/2. 1/2 base times height. Very good. All right. So we have 1/2. What's our base? 11.6246. And what's the height of our triangle? 8. Yeah, it's this opossum height there. So times 8. And then we just have to multiply by the number of triangles. How many triangles did we have in this pentagon? Yeah, 5. So we're going to times it by 5. So here we have, this is it. This is how we find the area. And I'm going to use my number. So I just want to take that answer and times it by 1/2, and times it by 8, and times it by the 5 triangles. All right, and then we get our area, which is 232 point, we're going to round to the tenths, so 0.5, okay. All right, questions on that one? All right, we're going to get used to this, so we'll go a little faster now that you have the basic idea. So here we have a polygon, a regular polygon, and you can see that the opossum is 2, it's labeled there, and we, again, want to find the area. How are we going to find the area of this polygon? General formula. What's the general formula? 1/2 base times height times, how many triangles do we have? I don't know. Number of triangles. That's what we're going to do. I'm just going to write it like that. 1/2 base times height times the number of triangles. Well, I need to figure out my number of triangles here. So let's see. I guess I want to know how many sides I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 sides here. So how many triangles am I going to have?
9, 10.
I have 1. Oh, babe, boy. I guess we better check this, huh? 1. I got too many different answers from you guys. 2. 1, 2, 3. Oh, wait. 4, 5, 6, 7, 8, 9, 10. How many triangles do we have? 10. 10 triangles, 10 sides. So the number of triangles we have is 10. Okay. So 10 triangles, 10 sides. What we need to know is the central angle. So I need to know the measure of one of these angles. What is that central angle? How'd you get that? Good. 360 divided by our 10 sides gives us a 36-degree central angle. And that's really only going to help me. I need to actually end up splitting that in half. So 36 divided by 2 is 18. So we get 18 degrees and 18 degrees for those 2 little baby triangles at the bottom. That's going to help me find the area. All right, so I have my base here, which is just this little bottom portion. And what should I use to figure out that base length? Tangent. So tangent of 18 degrees equals opposite B over adjacent to, because our opossum was 2.
How do you get 2?
They gave us the opossum. They gave us the 2.
Oh.
Yeah.
What's on 2 tan?
Yep.
18 equals?
2 times the tangent of 18 degrees is 0.6498. And now what we really need is the whole base. What is our whole base? Times it by 2. Good. So we get 1.2996. All right. So now we have our whole base. And so in my formula here, we're going to use 1/2 our whole base, which is 1.2996, times our height. What's the height of this little triangle? 2, and that's just the opossum. And then I can just use my calculator again. So times it by 1/2, times it by 2, and times it by 10 triangles. And so we get 12.099, which rounds up to 13. Okay. So again, pay attention in Delta Math. I can't remember what they're going to have you round to, but. All right, do you have questions so far? Do you think you can get the hang of this? Okay. All right, let's look here, number C. So again, this one says the opossum is 6. So again, that's from the center to the middle of the side. We have a height of 6. We want to find the area. So again, area is 1/2 base times height, and then times the number of triangles. Okay. We also have the follow-up question. What's the perimeter of this polygon? Which is easy to do once you know all this stuff. All right. So once again, I guess I need to start by figuring out how many sides I've got here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a nonagon, 9-sided. So we have 9 triangles. How do we figure out our central angle then?
360 divided by 9.
Good. 360 degrees divided by 9.
Divided by 2.
Yeah. Is 40. And then divided by 2 is going to give us our little angle that gets split right here. So each one of these is 20 degrees on that bottom triangle. All right, I need to find that small base. How do we set that up?
I do divide by 2.
We did that. I got my 20-degree angle.
And then you do tan 20 and
Tangent of 20
and 6
would be opposite over adjacent, so B over 6. And then we would multiply by 6.
That's 2.1838.
All right, so 6 times the tangent of 20, we get 2.1838. And if I double that, then I'm going to get the whole base. So times it by 2, we get 4.3676. All right. So then 1/2 times my whole base, 4.3676, times what's my height of my little base triangle here? 6. Good. The height was 6. Whoops-a-daisy. And then how many triangles do we have? 9. All right. So I'm going to take that 4.676 and just times it by the 1/2 and times it by 6 and times that by 9, and I get 117.9 for the area. Okay, now my question, how do you find the perimeter? Yeah, the perimeter. We know that the base is 4.3676. And how many of those bases do we have? 9 of them, yeah. So 4.3676 times 9, because they are all the same. And so I'm just going to go right back there and highlight my answer and then just times it by 9. And so we get 39.3 for the perimeter. So as we're doing area, very easy to figure out perimeter. Do you have a question for me on these? No, you got the just?
The
Okay, no, so it gets a little more complicated. Those are the easy ones. Oh, yeah. Okay. Okay, so those first three were given the apothem, and now we've been given the radius. So again, the radius goes from the center to a vertex, a corner of our polygon, but essentially the process is the same. We just have a little bit more information to figure out. So the first thing, once again, is I need to figure out how many triangles I've got. So 1, 2, 3, 4, 5, 6, 7. This is an octagon, 8 sides. I want to find the area, and I know it's going to be 1/2 base times height times 8 triangles. And I guess to get started, I still need to figure out my central angle here. What is my central angle going to be? 360 divided by 8 is 45 degrees. Very good. I'm going to draw in my bottom triangle here because it's missing something. What do I need to draw in this little triangle? The middle part, the apothem. And again, that's a word you want to know. But it is also an altitude. So when I draw in that altitude, I get my little baby base, which just got split. And then what happens to our central angle? It also got split. 22.5 for each of those little angles there. Got split in half. All right. So I need to figure out my base. I also need my height. I'm just going to call it H, because that's the height that I need to find as well. So now we have two things that we're going to use trig to figure out. I have my radius, which happens to be the hypotenuse. All right. So if I know the hypotenuse, what's a trig function I can use to find B? So I have the 22.5, and what is the B side going to be? Opposite. Oh, careful. So opposite over hypotenuse. Which trig function is that set up? Sine. Sine of 22.5 is opposite over hypotenuse. So B over 19. So be careful. You're not always going to use tangent. Don't get into bad habits. So opposite over hypotenuse would be B over 19. And again, we just need to multiply that 19 to the other side so that I get 19 times the sine of 22.5. And there is 7.2709 for my little b. 7.2709. I still need the whole base. What's the whole base?
14.5419.
Okay, so you just times that by 2. Good. And we got 14.5419. Beautiful. Okay. And then now I need to figure out the height here. I need to figure out my height. So which trig function am I going to use with the height and that 19? So using 22.5 as my angle. Cosine, yeah. So cosine of 22.5. Cosine is adjacent over hypotenuse. So adjacent would be the H, and the hypotenuse is 19. So again, we're just going to multiply that 19 over. So you get 19 times the cosine of 22.5. And that height, 17.5537. Fantastic. So now, to find the area, I'm going to do 1/2. My whole base is 14.5419. My height was 17.5537. And we had 8 triangles. So I can multiply all that together. So I'm just going to take that 17 and I'm going to multiply it by 1/2. And I'm going to multiply it by the 14. And I'm going to multiply it by 8. So I love, it's so nice, you know, once upon a time we didn't have calculators that did this. So we just had to type everything in. You don't have to. So we get 1021.1 for the area. Okay. Questions on that? Okay, let's just do one more just to make sure you got it, and then I'm going to give you a formula. All right, what type of polygon is this one? What's its name?
1, 2, 3, 4, 5, 6. It's a
Hexagon.
That's what I said.
It is a hexagon. It has 6 sides. What is our central angle going to be? 360 divided by 6 is 60 degrees. Very good. And then if we divide that by 2, that'll help us figure out our little triangle that we get to use. So 60 divided by 2, we get a 30 and a 30. That's going to allow us to find our base and our height. All right. We have a radius of 14. We want to find the area, and we also want to find the perimeter on this question. What do I need to do to figure out B here?
You just do sine equals
Sine of 30 degrees equals
over
B
14.
B over 14.
14 sine 30.
Okay.
I feel I can make them out.
You feel like you can do it?
Locked into it.
Okay, hey, that's good. 14 sine of 30 turns out to be, hey, 7. How about that?
That's right.
B equals 7, so our whole base is 14. That was easy. And then to figure out the height, we're going to use cosine. Cosine of 30 degrees is adjacent over hypotenuse. That's going to be h over 14. And so 14 times the cosine of 30. And multiplying that 14 over, we get 12.1243 for the height. Okay, so to find the area, I need my area of my triangle, so 1/2 the base times the height, and then times the number of triangles. And how many triangles do we have? 6. All right. So let's see, I'm going to take my 12, I'm going to multiply it by 1/2 and multiply it by 7, I'm sorry, not 7, by 14, and multiply by 6. So I have an area of 509.2, looks like. And then how's the perimeter? Yeah, it's just 14 times our 6 sides, and 14 times 6 is... Ooh, 84. Yeah, so all we're doing is taking this base length and multiplying it by the 6 sides that we have there. Okay, questions on that? All right, last thing. You don't know the area of a rhombus. The area of a rhombus. A rhombus is like that sort of diamond sort of shape. Not a parallelogram. Even though this one sort of looks like it, that's maybe a bad picture. Let me draw something less. Yeah. So here we go. So here's a rhombus, a better rhombus. And it turns out there's a pretty easy formula for the area of a rhombus. And what we can do is actually use the diagonals to figure out the area, because you can see, imagine if I were to take those diagonal lengths, they could sort of be rearranged. Yeah, they can be rearranged. Like if we were cut on the diagonals, you can take all those little triangles you created, and it basically sort of arranges itself into kind of like a triangle. So it turns out that the area of a rhombus is 1/2 times diagonal 1 times diagonal 2. So it is just half the product of the diagonals. And that works for any rhombus. All right. And so today in Delta Math, you get a little practice with just using those area formulas that we gave yesterday, half of them, and one more today. Do you have any questions for me?
No, ma'am.
All right. I think you can have a go.